Good evening, everyone. In this video, we'll be talking about state modeling, and we will also be discussing about the events. Okay, so we will also look at what are the different kinds of events which are possible. Okay, so we'll be checking about all these details. Okay, so we already have seen about the class models. Okay, so the static structure of a system. Okay, so the structure of its objects, how they are actually related, so that means like their relationships between the objects. Okay, at a single moment in time. Okay, so that's what was basically this sort of class model. Okay, the static structure of a system is concerned. We already have discussed this one in detail. Now let us start looking at state model. Okay, a state model basically shows how the changes to the objects and their relationships occur basically over time. Okay, so that's the basic state model is about. So it actually describes the sequence of operations that actually occur in response to some sort of external stimuli. Okay, so and we will be discussing about this one in the coming videos. So the state model actually consists of multiple state diagrams actually. Okay, what a state diagram will come, we will discuss in the coming videos. But the thing is a state model basically consists of multiple state diagrams. Okay, so a class model basically had multiple class diagrams. Okay, so are the class diagrams. Okay, so in the same way, a state model consists of multiple state diagrams. Actually, you will have one for each class. Okay, one state diagram for each class. Okay, with its temporal behavior. Okay, so how it actually changes over the time. But we will not be designing state diagrams for each and every class. Okay, so we'll be designing for most important classes. Okay, which have this sort of temporal behavior. Okay, and are also important for an application. Okay, so for those things we'll be having this sort of state diagrams. So in standard computer science, okay, so it is a very important concept. Okay, so say for example the state diagram. Okay, say for example it is the graphical representation of okay, so in terms of standard computer science, like the finite state machine. Okay, so that's also represented as a state diagram. Okay, so it is a very fundamental concept in computer science. Okay, and this actually relates to events and states. Okay, and basically an event actually represents some external stimuli. Okay, what it is we will see in the coming slides. Okay, and states actually represent values of objects. Okay, and the states we will be discussing in the next video. Okay, so again, to be clear, events actually represent some sort of external stimuli, and the states actually represent values of those objects. Okay, so let us look at first events. What are they? An event is an occurrence at a point in time. Okay, say for example if you are clicking a mouse, so mouse click, you are pressing the mouse. Okay, some activity happens only when you depress it, isn't it? User depresses the left button, then that's an event which is generated. Based on that event, something may happen. Okay, so based on that click event, something may happen. But then that event is that mouse button. Okay, user depresses the left button. Okay, similarly, say for example flight A123 actually departs from Hyderabad. That's one event. A flight which has a name AA123, okay, departs from Hyderabad. Say for example on a particular date. Okay, say for example today it goes. Okay, once it basically departs, that's an event. Okay, the event has occurred. Okay, an event happens instantaneously, so immediately it happens. Okay, with regard to the time scale of an application. But instantaneously, okay, say for example is it exactly at that moment? Okay, so it may take some time, but the thing is as far as the application is concerned, it is okay, so it is thought it happened instantaneously. Okay, if you want some sort of temporal phenomenon, something has happened in this time duration, or say for example during this interval, these things are better modeled with a state, not with the event, and that we will be discussing in the next video. Okay, so basically whenever an event is considered, like we assume like it happened instantaneously. Okay. The time at which like the event actually occurs is an implicit attribute of that event. Okay, so you don't have to specifically define that one, but then like it is assumed. Okay, so it's an implicit attribute for that event. Hope that is clear. Events may happen in such a way that one event may actually logically precede or follow another one. Okay. Say for example, like flight A123 actually departs from Hyderabad. Then after some time, like it basically lands in, say for example, Delhi. Okay, so that means like flight A123 departs from Hyderabad is one event. Later, after some time, like it lands in Delhi is actually followed. Then these two events are actually said to be like causally related. Okay, so one event, okay, the events are causally related. So an event happens after another event, or like one happens before the other one. Okay, that's about causally related events. But two events that are not causally related are said to be concurrent. Say for example, the flight leaving and then like say for example a mouse button being clicked. Okay, they are not at all related. Okay, so they can be concurrent. Okay, the events cannot influence each other. Alternatively, say for example, a flight A123 departs from Hyderabad. At the same time, like say for example, flight what is this? Some Indigo, say for example, 235 basically departs from Bangalore. Okay, this event happened in Hyderabad, and the other event happened in Bangalore. So they are also not related. Okay, so they are considered as concurrent. Okay, in modeling a system, causally related events, like we model them in such a way that say for example one event happened and the next event happened. But in modeling a system, like we do not try to establish an ordering between these sort of concurrent events. They are not influencing each other, so they can happen at any time. Okay, that's a very important difference between these causally related and then like concurrent events. Actually, events also include these sort of error conditions along with these normal occurrences like the flight leaving or something like that. The error conditions, say for example, like some motor jammed or like transaction aborted or timeout. In theory, like these are all the events which have actually happened. So it is only our perception like there are some error conditions. Okay, they are actually representing some error conditions. Okay, a transaction aborted. Oh, it is an error. Okay, so it's an event occurred. Based on that one, like you have to do something. Okay, so that is like which we will not worry at this moment. Okay, but then like an event has occurred. So even a transaction aborted is also an event. A timeout, even though it's an error, it's a event which happened. Okay, so try to know that difference between those things. Okay, so it may also include these sort of error conditions. There are several kinds of events possible. Most common of these are like signal event and the change event and time event. Okay, we'll be discussing these three in detail. Let's first look at the signal event. Before we actually look at the signal event, let us see like what is a signal. A signal is an explicit one-way transmission of information from one object to another. So there are two objects existing. So it's an explicit way of one-way transmission of some information from one object to the other. Okay. It's actually different from, say for example, like a method being called or like a subroutine being called. Okay, from one method to the other. Okay, one object to the other. Within like say for example, one method of object one basically is calling the object to some other method. Okay, we should not be thinking like that one. It is actually different from the subroutine call that returns a value. If you purely think in terms of a signal, okay, an object sending a signal to another object may expect a reply just like the subroutine, but the reply itself is a separate signal. Okay, you have to think like that. Say for example, if it is a subroutine call, like you will basically send a request and then like you will basically get a response. Okay, so if it is not void and then like if it has a return type, you will basically get it. But signals are not like that. Signal is an explicit one-way transmission between of this information between these two objects. Okay, and if say for example object 1 is sending a signal and if it is expecting a response, okay, The response is also a new signal which has to come back. And now the sending of the reply signal is under the control of the second object. And this second object may send it or may not send it. You see? That's about the signals. A signal event is the event of sending or receiving such a signal. So we discussed what is a signal. Okay, so an explicit one-way transmission of information. And a signal event is the event of sending or receiving such a signal. Okay. Usually we are more interested or we are more concerned about receipt of a signal, because like say for example if we are designing an object, receipt of a signal is really critical, because based on the signal it received, it causes some effect in this object. Say for example if you send a signal, whatever happens to this particular object, it's a different object which will be in a different class diagram. Okay, it's belongs to a different class, then it could be in a different what do you call state diagram. Okay, but then like we are always concerned about the receipt of the signals, and the receipt of a particular signal will cause some effects. Okay, some effects in this sort of receiving object. So to be more precise, like the difference between signal and signal event is concerned, a signal is a message between the objects. Okay, that's what we have discussed. And a signal event is an occurrence of such a signal in time. Okay. Every signal transmission is a unique occurrence. Okay. So that means like say for example whatever okay, so the signal transmission, it is unique. But in we generally group them together into signal classes, just like the way like we have modeled the classes, even the signals can also be modeled as the signal classes. Okay. Say for example like think about this flight departure signal. Okay. We have given the example like flight. Okay, so which is like a, okay, airline is like say for example A, so then it is like Air India. Okay, Air India flight number A123 has departed from Hyderabad. Say for example the date is today. That constitutes one signal. Okay, so there can be several signals. Okay, each signal transmission, so that is like each so such an event. Okay, so is basically unique. Okay, so that means like the signal can be represented like this one. Okay. So similarly, like say for example a mouse button pushed can also be a signal. Of course UML notation is like you will have this so these symbols. Okay, so and then like you basically will put signal there. Okay, say for example mouse button pushed coming back, so that would be a signal class. Okay, so its attributes will be like signal attributes will be button and location. So which button you click, so left or right button. Okay, and then like say for example location and which part of the screen, so for example which pixels. Okay, similarly say for example if an event, if a signal is string entered, so the attribute will be what is the text you have entered. Say for example even if you think in terms of receiver lifted from a phone. Okay, so that's also a signal. Okay, say for example if you dial a digit, what is the digit that you pressed? Okay, so that's also a signal. So signal classes. So signal classes basically summarize all of them. They basically group all such things. Say for example dialing 4, dialing 5, dialing 8, say for example any other number, okay, any other digit on a phone. Okay, so all of them will be constituted together, okay, grouped together into this sort of digit-dialed class, signal class. Actually, that's about signal events. Then there are also these change events. A change event is an event that is actually caused by a satisfaction of a Boolean expression. Okay, so the expression is continuously tested. Say for example, let's look at an example. If you have some sort of heating existing in this room, or like say for example, let us think about the other one. So in India, we are more worried about having air conditioners rather than heating. Okay, so in Estonia, from where like I came here, we have the heat because there is a lot of snow around. Okay, so the other example would be a lot more logical. Say for example, like if you set a cooling set point, if the room temperature is greater than that point, okay, room temperature is greater than that cooling set point, so that's an event. That's a change event that has happened. Once such an event happens, like based on that one, like you may trigger something. Say for example, something like you will turn on the air conditioning system or whatever it is. So whenever we are thinking about events, like we don't care about that sort of triggering thing, but the change event has happened when the temperature, okay, so the cooling set point and the temperature is greater than the cooling set point, okay. So as I said, like this sort of change event is that is caused by the satisfaction of this Boolean expression. So this Boolean expression, so in this case like temperature greater than this cooling set point is continuously being tested, room temperature, okay. When the value changes from false to true, the event happens, okay. But what we have seen is like the event is an immediate thing, is it true? Okay, it happens instantaneously. So that means like, are we going to check these things continuously? So all the time? Probably not. In terms of implementation, we will try to check it very often enough, but not continuously. Okay. So in terms of performance, that is not efficient. In terms of UML notation for this sort of change event is concerned, okay, when is actually followed by a parenthesized Boolean expression. Say for example, here are some of the examples. When room temperature is less than heating set point, or like room temperature is greater than cooling set point, or like say for example, when battery power is less than some lower limit. Okay. These are all change events. Say for example, when tire pressure is less than the minimum pressure. Okay. You can think about a lot of different sort of change events. Okay. Here are some of the examples. Then the third type of this event is this time event. Time event is an event caused by the occurrence of an absolute time. Okay, that's one way. Or like the elapse of the time interval. I'll give both the examples. Say for example, when date is equal to today, I mean like, okay, when the video will be seen by you, all of you guys, okay, so which is March 24th, 2021. Okay, the date is equal to March 24th. So that's also a time event. So which is like an event caused by the occurrence of an absolute time. Okay, or like it can also be based on this sort of elapse of a time interval. Say for example, after 10 seconds, or like after some 2 days, or something like that. Okay. So the UML notation for these sort of time events is basically like when followed by say a parenthesized expression involving the time. Say for example, here it is like date is equal to March 24, 2021. Or like after followed by the parenthesized expression that actually evaluates to a time duration. So after 10 seconds, after 2 days, something like that. So these are different types of events. So as far as reference is concerned, now we are in chapter 5 of this object-oriented modeling and design with UML. Thank you, Laha and James. Thank you very much for your attention.